Scientists, staff operating in war-torn regions, and teams dealing with natural disasters have a difficult time analysing situations over big and possibly dangerous areas. One of the organisations requiring accurate information in such places is Doctors Without Borders, or the MSF. They give medical aid and help people in crisis all around the world, but need to prioritise areas in need depending on the seriousness of each situation and the number of people involved. Estimating these things by visiting the location or use satellite images that often are outdated can prove both unreliable and time-consuming. But the problem can be solved. Key requirements for a suitable solution are to capture data and videos in a short amount of time and transmit them to a base station in an easily consumable format. This is why we want to introduce MediDroid, a solution to the problem. We will use a drone flown by a drone pilot to gather data and video footage. It will be linked to a Google Cardboard to provide the medical cardboard user with visual information of the area of interest. The cardboard is extremely well suited for this purpose. It presents the user with a 360-degree virtual reality. It's light and little and very easy to travel with. Doesn't need electricity apart from a mobile phone which slides into the cardboard. And by using the cardboard, we allow a broad use group in various environments to gather and analyse data in a simple but very effective way. For the other parts of MediDroid's system, we researched various other hardware components. We looked into whether to make use of a ready-made drone or build our own drone from scratch. A custom-made drone would take a long time to build, but we could link the sensors and the cameras to the data transmitting system of the drone. If we bought a ready-made drone, we would have to create an independent system for the MediDroid, as most software will be closed source. But we would have the option of integrating the individual system to a custom-built drone later on, which is why we chose to use the ready-made drone. To record and send data from multiple sensors, we need a microcontroller, so we looked into both Arduino and a Raspberry Pi. If we were to change to a custom-built drone later on, we would have to integrate our system with a drone's flight controller, most of which are Arduino-based. So we added an Arduino to our design. To transmit data between the server and the mobile phone, we chose to use Bluetooth as it works well when the devices are close together, and the server would be close to the cardboard user at all times. Bluetooth or Wi-Fi would not suit to send data from the drone to the server, as it would likely fly out of range. So we used the long-distance radio telemetry, which has the same reach as the connection between the remote control and the drone. Our research on sensors and video feed, useful for the attended users, led us to use a temperature sensor, light sensor, air quality sensor, a GoPro, and an infrared camera. When added all together, all of these make up the MediDroid system. For the software part, we researched which programming language to use, Java or C. As our primary operating system will be Android, and Android is based on Java, we chose to code using Java. For graph drawing in the application, we saw the option of using HTML and JavaScript or OpenGL-ES. After research into HTML and JavaScript rendering in an OpenGL-ES environment, we concluded that creating the graphs with OpenGL-ES itself was the most effective method. And by trial and error, we created a basic Google Cardboard application. When starting to think about data visualization, we realized that there were three crucial ways to present data: by showing a video, drawing a graph, and displaying crucial current data values, each of which could be used once or for multiple data sets. We initially created 4 different concepts of the main menu for the application. The first one consists of individual menu boxes displaying live data. Each box can be made full screen by clicking on it. The second one is a list of display options to be shown full screen when clicked on. The third one shows graphs with live data on top of a large drone footage. And the fourth one displays the menu items in a circle, allowing the user to tilt his head to scroll around. We showed and explained these prototypes to 5 intended users who gave feedback and picked their favourite menu option. This left us with the options on the left-hand side that we used to create the prototypes of the application. This is the first prototype as seen on a mobile without the Google Cardboard. With the Google Cardboard attachment, the user feels as if he's watching a menu right in front of him. The prototype shows graphs and a video as the menu boxes. When the user is looking straight at a menu option, the option will get bigger and change colour to indicate which item is being looked at. If the user presses the button on the cardboard, the graph or the video being looked at becomes full screen. The second prototype has the same features as the first one, indicating which graph is being looked at to enable the full screen function. The downside, as we can see, is the specific details of the graph or the video can be difficult to see. For feedback, we asked a group of users to try both prototypes using the Google Cardboard, and the overall feedback led us to move forward with the individual boxes prototype, which we will be further designing at the next stage of the project. We've achieved a lot so far, but still have a way to go. We have created a 3D virtual reality view in a Google Cardboard, created graphs using OpenGL-ES, created a server, transmitted data from a laptop to the phone via Bluetooth, created a working prototype of the overall system, and learned how to fly drones, understand the aerial view they are able to capture, and see firsthand the speed at which an area can be assessed. The next step in our development process is to implement head tracking with a gimbal. A gimbal is a pivot that allows the rotation of parts along a 2D or a 3D axis, and will in our case have a GoPro mounted on it. When the user selects the live drone footage from the menu, making it full screen, moving the head will no longer be used to look around the screen, but to control the gimbal on the drone. When the user tilts or turns his head, the direction of the camera will change, allowing the cardboard user to control which direction he is looking, and a verbal communication between the drone pilot and the cardboard user is no longer needed to change the direction of the view. For our next prototype, we will also be looking at adding and connecting a heat camera to the MediDroid system. Adding a heat camera footage could be very useful to locate people and to estimate the number of people, such as refugees, at a specific area. And this is what we intend the MediDroid main menu to look like for the next prototype. The Google Cardboard user can see the live sensor feed on the right-hand side, displayed as graphs and individual current values. On the left-hand side, he can see the view from the drone as seen by a heat camera or a normal camera, allowing all menu boxes to be viewed full screen when clicked on, and turning the Google Cardboard into a camera control when the normal video is viewed full screen. This is it for now. We look forward to bringing you closer to a ready-to-ship MediDroid application in the near future.